Last session, we were looking into primarily the Kubernetes architecture, and also we looked at it's more of a theory that we had. A lot of theory was there, so I had to explain the theory. So I think today we'll go more to the practicals, but just a refresher. I think in the last session we looked at what is Kubernetes architecture, and also what are the various components inside Kubernetes. I think what Kubernetes is doing many things, but what is there behind the scenes? So how we can do many things, and what is the coordination between a master and multiple nodes? So we looked at more into the Kubernetes architecture. Just to summarize, so Kubernetes architecture has a master or control plane who will provide inputs to the minions or workers or nodes. So I mean all are similar. I mean they're all same. Node or worker or minions, they're all similar. So basically we have, but the node is nothing but a virtual machine. So say we can create a cluster with three virtual machines as nodes, and there will be one master, and master will give instructions to the nodes, and the real execution of work is happening in the nodes. So, but master will just direct, get instructions, and ensure that everything is working fine. So the master is just a driver. So and of course, what are the kubectl commands that you provide? So you actually are giving some kubectl commands. So actually you're interacting with the master, especially the kube API server, which is the core component in the master. And kube API server has multiple hands. So it talks to one side, it talks to the nodes. One side it talks to the end user who is giving inputs. I think I didn't put this in diagram, but I think you can imagine there's a end user giving instructions, kubectl commands. So that is one hand, and also it also talks to all these three other components within the master. So it's like it's a QAP server is like a multi-hand worker inside this. So yeah, so and he stores all the information in a database called HT, and of course we also looked at kube scheduler who will give directions to master to the kube API server in terms of where this particular pod has to be installed, because there are multiple nodes, but which node to pick to install a pod. So do we pick all three, or do we pick one pod, the one node? So all the instructions, the scheduling aspect is all taken care by the scheduler, kube scheduler. And also when you have to talk to cloud, then there's another component called cloud control manager, who will also talk to the API server, and any components where, for example, if you're using Google Cloud or Azure Cloud or AWS Cloud. I mean, I'm talking about the Kubernetes component equivalent. So it will talk to the this module within the master will talk to the respective modules within the cloud. For example, if you're using GCP, which is Google Cloud. So this module will ensure that all these virtual machines are created on Google Cloud. Similarly, Azure, it is Azure virtual machines, and if it is if it is AWS, it's AWS virtual machines or EC2s. So similarly, the load balancer component, again, that is also cloud specific component. So basically virtual machines and load balancers. These are two. Of course, there are other things are also there, but I think these two are primary things which this cloud controller manager will talk to the respective cloud. For example, if you're deploying this in your on-premise, then this doesn't have any role. I mean, if you're doing everything on-premise, then Kubernetes also can be set up on on-premise, right? So then this doesn't have any role. And also we looked at controller manager, which will ensure that all the respective replicas are maintained correctly for pods and containers. The container states are all valid. So all that health parameters of a pod and container are managed by this kube controller. So summary, kube API server is the main guy which talks to everyone inside and outside. Inside is I'm talking inside is this box, which is a Kubernetes box. Inside it will talk to various nodes. Outside it will talk to the end user. It uses status. back and accepts input and gives a status back. So that is the kubefs server. So this guy is like a public speaker in a political party, right? Who will give his face to the outside world. So likewise, he is the face to the Kubernetes. And of course, but he takes inputs from a lot of other people who are behind the scenes, and also he also talks to the nodes. And so yeah, summary. I think we looked at all these things. QBP server validates and configures the data, acts as a gatekeeper for the entire cluster, and communicates with the external world. So scheduler schedules the pods across multiple nodes based on the resources. Then controller manager coordinates the entire cluster, um, and also monitors the health of the nodes and pods. So this is the controller manager, sorry. And this cloud controller coordinates interaction with the cloud resources. And HT, this is the key value store database. This is a NoSQL key value DB. It is just centrally stores the state of all the cluster, and it acts as a single source for master and the node states. So this is all at HT. By the way, HT you will not be able to directly query HT. It's a hidden component inside Kubernetes. So you don't even know that you can't even access this HT directly. And other thing that you need to know is typically in a managed Kubernetes where you're, for example, if you go to all the cloud vendors, the Kubernetes is managed by the cloud vendor, right? So in that aspect, this control plane is completely managed by the cloud. Um, but so basically you'll not be able to connect to this VM where this master is running. So you'll not be able to connect it because it's a managed service. So it's done by taken care by the Google or Azure or AWS guys. But you have complete control to connect to any of the nodes. Nodes is completely in your control. I'm talking about a managed Kubernetes scenario. But if you're doing the setup on an on-premise, then of course you can connect to this VM and have complete control. So that's the difference between managed and unmanaged. Unmanaged is you need to manage it. Again, why this only this part is given as managed service by the cloud is this is the toughest component. I mean, this is the as an administrator. I mean, there are two roles in Kubernetes, right? One is a developer, a Kubernetes developer, and also there's an administrator. Administrator's role is to set up this entire architecture for an enterprise. So, and as administrator, he has to manage many things inside this control plane, which is a tougher problem to solve if you are doing it on-premise. Of course, it's not impossible. I mean, it is possible, but that you need to manage many things. But let's say you don't want to take that headache, right? So in that case, you can go to any cloud and take this managed services so that your responsibility lies in just creating a cluster and telling what version you need. That is a max input that you provide to a master. But yeah, how many nodes you want? So that is the input that you give. That's all. So the entire thing is managed by the cloud. So yeah, so that is the difference between managed Kubernetes and an unmanaged or on-premise setup. Let's go to the nodes. I think we're done with the master. Let's go to the nodes. I think nodes is very simple. Nodes is nothing but a virtual machine. So the components inside this primarily we know it is pod, and pod of course pod will have multiple containers inside. But in addition to pod, we also have kubeproxy and also kubelet. Kubeproxy is from the name of the proxy, which means a networking component. So which primarily manipulates the IP tables on each nodes so that one pod can talk to other. I mean, this pod in this node, if it wants to talk to this pod in this node. So generally, I mean, you can access it. I mean, it's just like another application deployed in another VM. How you access it? So from one VM, if you want to access another application deployed on another VM, you will instead of localhost, you will use the IP address of the node. So HTTP colon IP address of the node colon port followed by the API service. So same way. So you will access the IP address of this pod and then invoke it. But who will give the IP address? The IP address is and who will manage the network like you can access this, but not something else. So who will manage that networking stuff? So that is done by the kube proxy. So the kube proxy takes care of the networking component within the node cluster. So, and also this kubelet. Kubelet is actually the agent which provides the health details to the control plane. We go back to this diagram. So this kubelet is actually the master should know the health of the each nodes, right? So if any given time a node is down, it should not route the traffic to this node because this node is down. So it should send traffic to the other two nodes. So so a node can die down or a pod can die down. So these are two possible cases where a node can die down or pod can die down. So in that case, the kubelet is the one which knows that information as a first hand, and kubelet will pass that information by looking at the arrow mark. It will pass the information to the kubelet server. So this kubelet plays a major role in tracking the health information of the node. So yeah, so that I mean typically in a clustered architecture, distributed architecture, there will be always it is important to know the health of any given system. So someone should monitor the health so that a master will should be informed that someone is not good or someone is not healthy or someone is not accessible. So that health information should be given to the master. So that role is done by this kubelet. So so summary, control plane will have QAP server, HT, and QAP server talks to multiple nodes, um, and uh, and also it maintains status, health information of all the nodes. All the information that is being passed here is all stored here in HT. So that's how QBP server knows that what is the health of any given node. And also scheduler will schedule the spots, and the cloud controller will manage the cloud operations. This guy will ensure that the health is health is all good. So it manages the health of all the pods and other stuff. So and this node is actually the as kubelet, which gives the health information. Proxy is for networking. Pods, I think we discussed a lot. So pods are actually your code binaries, which are deployed here as containers. Of course, in this for this containers to run, you also need a container engine because container engine typically is a Docker is what is used, but of course Docker is one container engine. You can replace this with Cryo or something else also as a replacement for Docker. But the Docker is mostly used the container engine. So yeah, so you need to have a container engine, which I didn't depict in this diagram, but it's understood that container requires a container engine. Um, and these are the must-have components inside a node. But there are optional components in Kubernetes that you can add as add-ons. The add-ons could be a UI, which I mean there's a UI. Kubernetes UI is also there. UI user interface, and also DNS, which is primarily for domain naming service. Primarily, all this all having an IP. So you are interested to associate a domain name like google.com, for example, to a particular IP. So you can associate a domain name also in Kubernetes by introducing these add-ons. So of course, a lot of add-ons are there in Kubernetes, and every day it is growing. So we can choose what add-on you want. So that's about the node. So any questions in the architecture before we move on? I think this is all we discussed in the last session. I'm just giving a recap. Okay. There are no other questions. Then let's move on. Yes, I think this YAML is the basic syntax. I think so far we never. I mean, we saw command line utilities with kubectl command line utilities. That is, kubectl command line utilities are easy for if you have to manage single application. But in real time, you have to take a lot of knobs, right? So I mean, there are a lot of knobs in Kubernetes. So the best way to represent or give instructions to Kubernetes master is through YAML file. So YAML is the name. It is a reverse acronym for 8 markup language. It's a similar to JSON, just that it's a key value pair at the end. So, for example, key value pair is something like this, like fruit, orange, vegetable, carrot, like this. So it's a key and a value. So let's say it's a key value pair. And then of course there is a space which is important that we need to remember. There's a space in between after colon and the value they're giving. So and YAML also can accept various collections like array list. For example, if you have array list, then you need to associate a hyphen before it, so which indicates that whatever is coming under this or like array list, array values, like fruits in this case is an S, like it's a plural, which means it can have more than one value. So yeah, you can have a hyphen before each record. So that denotes an array list in a YAML structure. And dictionary also it is possible to have. For example, a key orange, for example, can have various values like carbs, fat, calories. So if you have a structure like this, so it is like a map. Right? It's a key value pair. It's all in Python terms also called dictionary. So you can store key value pairs under it, but here it is not an array list like here. So it's just a key value pair. So that's about, so basically you can use array list and key value pairs, and also you can use a combination of these two also. That is what is this structure. In fruits you have apple, oranges like this, and inside this I'm embedding this under apple or orange, for example. So that will look something like this. So it is a combination of an array list and a map. So this is all. I mean, this has nothing to do with Kubernetes. This is typical YAML structure. I mean, it's nothing to do with Kubernetes here. But I'm just giving some basics about YAML before we move to the YAML structure. So at the end, it's a key value pair. There'll be we can store array list, dictionaries, and combination. That's all. Nothing else. So this is a simple data structure. And yeah, so Kubernetes mostly uses YAML as a syntax. Of course, you can use JSON also. So it is possible. I mean, Kubernetes supports JSON also, but I think what mostly used is YAMLs. So yes, so a typical YAML structure. This is how it will look like. For example, this is a key value pair. So so yeah, before going into this, probably I have this. Yeah, this one. Yeah, so in any Kubernetes YAML files, I think let's understand the terminologies first. So the Kubernetes has various terminologies. They call as objects or Kubernetes objects. The Kubernetes objects, if you look at, I think we already saw most of the objects. Like for example, we saw replicas, the replica set, right, which will maintain how many replicas of pods you want. 3 instances or 6 instances or whatever. So how many replicas you want. So that is so replica set is one object, and similarly other objects are deployment. So like you have to create a deployment of for and telling what pod you want to deploy. So that is what is deployment. And other object in Kubernetes is services. So if you remember, if you recollect the examples which you did earlier, so if you look at this is actually creating a deployment. So you're creating a deployment name and your image you're giving. So this creates a deployment file for you. So when you create a get deployment, it is giving you the deployment name. So it gives that. So and similarly, you're also exposing this as a service. So service is this. Of course, you can do a get service. So if you look at this is what I was referring. So deployment service, of course, pods are the basic entities, but deployment service, replica set. These three are important aspects. So you generally define them in a YAML structure. So deployment service, replica set. So let's start with the replica set, because replica set will have pods because when you're telling a replica set, you generally give, if you remember these commands we tried before, the replica set, what is that, replicas, yeah, here. For example, here you're using a replicas, what is that? So you can scale, for example, the replicas to from 1 instance to 3 instances, for example. So basically, what are you replicating? You're replicating the number of pods. I mean, earlier by default the pod is one when we ran this command for the first time, but you can increase the replicas to three. So basically, replica set at a high level will have the pod details because it should know the pod details. So the pod details should be explained in the replica set. So that is what I'm coming to here. If we go back to the YAML structure of a replica set, so you'll have the pod. You'll have. I mean, look at these primarily. I will come back to this structure, but you will tell how many replicas you need, and also you will tell what is the container that you want to replicate to from 1 to 4 or 5 or whatever. So you need to tell the containers which containers you want to replicate and what is the count. These are two things that you need to remember in a replica set. So just to go back then, so if you look at these are the various objects. I think first let's look at the replica set. The replica set, if you look at this YAML structure, so everything in Kubernetes starts with these four: API version, which is it starts with API version. Here we will tell what is the version name. So it will be v1 or app/v1. There are various. It just tells what is the version of API that you want to use because Kubernetes is changing every day, right? So just to maintain the backward compatibility, they give the versions. So v1, v2, you can tell what version of Kubernetes you want to use. So that's what is the API version. So everything starts with an API version. So mostly you will have values like v1 or maximum in some cases it's app/v1. So mostly this is what you use here. In this replica set is v1. And other thing is once it's done with API version, it is kind and metadata and spec. So these are the parent elements. So in any YAML file, these are the four guys that you need to know: API version, kind, metadata, spec. So kind is the one which tells, but everything is YAML. This kind is the one which tells what is this file all about. Is this a replica set, or is this deployment, or is it service? So that is what is that. The kind is what it tells you what this YAML is about. So in a replica set case, it is a replica set. Uh, for example, in deployment case, it will be deployment. In a services case, it is service. So yeah, in this case, it's the replica set. Right? So basically, first thing in any YAML that you open, kind is what you first look at. So that will give you an idea of what is this YAML for. So if it is a replica set, then yeah, you're talking about the replica because the contents inside this YAML structure will change based on the kind. So I mean, replica set will have set of keywords and deployment will have set of keywords. So it's a slight difference. So yeah, so replica set. So first thing when you open a YAML, you really look at the kind and identify what is that this YAML for, and then this metadata is just a key value pair in terms of labels. Generally, you will have labels here, labels for pod. I mean, in YAML is case sensitive and indentation sensitive. So you need to have proper structure. I mean, if you're giving, I mean, this is something, or if you want to add this as a child, you should give two spaces and then give a child. Uh, so this means that labels is a child of metadata. So yeah, in labels, you tell again this label is uniquely to identify what is this pod is for. Generally, you'll have app and then your name of the pod. So this is what you generally you can give any name mechanic. It's up to you. But just to identify that when you do a kubectl get replica set, the get outputs. This is a name that will be displayed. So just to identify, so it's good to have a name which you can identify easily. So labels, and then you'll have so that's about the and then name. These are two things that we generally use. Namespace is optional. Namespace is the one which tells I will tell about namespaces later, but I think namespace is like it's like a package where you want to deploy this code. I will come to that namespace later. For now, you can assume that if you're not telling anything, default is a namespace. So that's about the metadata. And then spec here is where you will actually tell RST. I mean, that's how I remember this replicas selector. Sorry. I mean, again, these are all not mandatory for you to remember this because I will show you all these IntelliJ or other IDs. They have fancy tools where you can get this auto generated. So I will explain that to you. But at a high level, you need to remember some syntaxes because when you really deploy this in production, right? Production, you mostly deal with Linux files, Linux or Linux machines, and you try to troubleshoot it. By the time you will not have any editors in Linux environment. So then, yeah, so it's important for you to know this structure at a high level so that you know what will come under what at least. So that's why doing it, practicing it in a notepad or where there is no editors, then you will remember things. And that's how I practiced it. So that's how you remember the hierarchy at least. Um, yeah, so this RSTT is a template. So this is so these are three things under spec. Since it is a replica set that we're talking about, the replicas, how many replicas you want, 1 or 3 or 4, and again you need to have a space because it's common for everywhere. And selector is again the what is how many it will have the label information again. Basically, while you're replicating these instances to 4, where it will make use of the labels information. So what are pods matching with this labels? So that will be used. So labels, match labels is what you need to use. Match labels. When you're incrementing the pod by four, you need to increment the pod with the labels matching this information. So here and here name of the pod. This case is all about REST API. Right. So that's about the selector, and then here in template again you need to tell the metadata. Again labels, again the same thing, whatever you see, and the spec is what is important. Sorry, the spec is what is important. Spec actually tells you the container information. So just copy pasting this label stuff here. And this, yeah, so this template has metadata and spec. The spec is the one that actually will have container information. So what containers you want to deploy. So that is what is mentioned here in containers. And here you will tell what is the image that container image that you want to deploy. In this case, my image is this is a Docker image of my Hello World application. So and followed by the colon release information. For example, what version? For example, you have the version information. Basically, the image name colon tag information. So that is what is this. So that since here it is possible to have more than one container deployed. For example, if the microservices, there will be multiple containers that you have to deploy. So that's why it is an array list. So you should have an hyphen before it. So of course, this means is that you can have another image also. That it is possible. In my case, it is not applicable, but I think. For example, typical microservices, you can have it's an array, which means you can have more than one record like this. Image 1 could be 1, and image 2 could be 1. So likewise. So yeah, in my case, it is just 1. So I'll put an image pull policy. Again, this is pull policy is the one which tells that I need to what this image, if is not available, what should be the policy to pull this image, because everything works on pulling an image. So you need to tell the policy if you need to pull this policy if not present. So which means if this image is not already available on this machine, we will try to pull this image from the Docker hub. So that's the meaning of that. Again, the last one is the name. The name of the pod. Yeah, I think this looks daunting for the first time, but I think once you practice this multiple times, I think you'll commonly easily identify it. So this is a replica set. So probably I will just quickly move to the demo section. I will, yeah, sorry, reconnect. Yeah, so this is I am going to GCP, where again I'm just going to the same Kubernetes cluster which I created earlier. So this is a Kubernetes engine. I'm going inside clusters. Under cluster, I have cluster one, and basically this is cluster, and we have 3 nodes. So 3 nodes are there. So I already created this, just kept it ready. The same thing that we were using before also, nothing different. So now I'm trying to connect to this cluster. This is a project. This project ID is what you need to give, so that now we are connecting to this cloud, to this. We're giving instructions to connect to this shell, right? So now we are connected. Let me check if I go access. Get a look at ports. Everything is there. Okay, it's already there. Let me first. I think these are the old ones that we use. I'm just deleting it. First, since we need a replica set, I will delete the pods and replica set. So let me quickly delete this. What is the delete command? Yeah, yeah. It will delete. First, I need to check what is the RS is a replica set. First delete the replica set, because if I delete the pods, because the replica sets will kick in and it will create the pods again. So I need to first delete the replica set. I'm just trying to. These are the old ones which we already created. I'm just deleting them so that I can run this this YAML file now. Very slow. Delete RS. Sorry. Okay, so I deleted this. So kubectl delete pods. Okay, so delete all command can be used because there are more than one. So you need to tell what is the pod ID. Delete all we can use, so it will all delete in one shot. So this is the command to delete all the pods in one shot. So of course it's only one. I should have given delete pod ID. I should give. So that's why it's asking for pod ID. So if this is faster, let me delete this service also. Okay. So now let me run these 4 commands, the get commands, to see everything is deleted. And these are the ones which we created earlier. So I'm just deleting it, and these are the commands that we created earlier using kubectl without YAML files. We created this the create deployment, expose deployment. These are things that we used before. Now I'm going to do the same thing from using YAML file. That's what I'm trying to show now. So Now let me put all these get commands to ensure that nothing is run. Uh, and is there? 1 minute. Um, that's good. So now let me run this get stuff. Okay, yeah, this looks good. So basically, I did all gets now just to ensure that nothing is there. So get deployment shapes is telling no resource found. Get service is telling no only one service, which is Kubernetes specific service, nothing to do with the hello world, which is this Kubernetes service. That is okay. And get pods and no resource found, and get replicas at no resources found. So this I cleaned up everything. So we are go to clear screen mode so that yeah, we can start from fresh. So what I can do is so this is the same PPT content that I have here. I will create the same thing in YAML file as a YAML file. Of course, I can use a VA editor and create it, but just for time's sake, I just copied, created this replica set already here. So let me open this just to show you the content. So this is the content already open VA mode, so that it's more clear. So VA mode is I mean, it's already next command. I mean, just so I assume we all know the next command. So it's just a VA mode to open the file. So it is yeah. So whatever is there in this PPT, nothing. The same command is what I have put here. So this is a YAML file. So apps v1 replica set, and you're telling what is your metadata information, and then spec how many replicas you need. You want 4. I'm telling I need 4 replicas, and what replicas of what? The replicas of this container, Shamnar and 2001. This all over REST API. This is my Docker image, which I already hosted in Docker Hub. So basically, I'm telling this is I have Hello World REST service. So this Hello World REST service, I need 4 replicas and create that using the replica set. And of course, I'm just telling what are the label names. That's all. So that is a summary of this replica set. So to run this command, out. So to run this command, so you will use this command kubectl create -f is for a file, and then followed by the file name. So this is kubectl create -f and the YAML file name. That is syntax. So I'm just creating this. Before that, I'll just ensure that kubectl get RSR replica set is no resource found. Okay, so let me now create it. Kubectl create -f 01 replica set. So okay, so it's already there in the same folder. I just it recognizes this file, so it says this file is created. So now if I type this kubectl get rs command, you should see the desired instance of 4, because in the YAML file we gave this replicas as 4. So that's why it is creating 4 replicas. The replicas of what? So it should be the replicas of our pod, which is get or pods. So these are shortcuts. PO or pods both will work. A replica set or RS will also work. So here it replicas of what? Replicas, it created 4 replicas of your Hello World REST API. So where did you mention that? So here is where you're telling to use this image Hello World REST API and replicate this as 4, and the name should be Hello World. The last word, the Hello World REST API. This is what it used here. Hello World REST API with the name. Of course, it appends the unique ID at the end, but at the end, yeah, you get these 4 instances. So basically, now we gave this entire command using a YAML file. So yeah, so that's about the replica set. Right? And now let's go to the deployment. So let's say you want to create a deployment. So the deployment also follows the same structure. Again, everything starts with the 4 pillars in Kubernetes. Even if I wake you and ask you in the night, you should tell what these are. These are the 4 pillars: okay, API version, kind, metadata, and spec. These are 4 things that parents. So under this, a deployment will have a app/v1. That's what I mentioned here. V1 or app/v1 also you can use. But here in deployments, it is app/v1. And kind is already mentioned. For replicas it is replica set, but here it is deployment, so it is deployment. And metadata again, here you tell what is your label stuff. Labels again, you can, it's again, Kubernetes doesn't say what how to use this. You can free to use any label name. I'm just using the same label names that I used here. So name, Hello World REST API, the name, and the namespace. So these are the things that I'm using here, same like above. Spec also here, same here, RST, which is replicas, selector, template. And under this, under template, you'll have say metadata and spec. RST, MS, that's what I remember from metadata. RST, MS. This is API kind, metadata. Let's say API version, kind, metadata, spec. These are the parents. Under spec, you'll have RST, replicas, selector, template. Under template, you have MS, metadata, and spec. So, and this is spec is what is important because the spec will have actually the container information. So this is for a developer, this will be more important. So containers, and you will tell again containers can accept more than 1 record. So you have hyphen and then image, and then followed by this, you'll have the image pull policy. Again, this is not. Even if you don't mention this, also it's fine because image pull policy, if not present, is default. But there are other pull policies also. So this image is not available, then whether what should be should error out or not. So that is what it means. So image pull policy means if this image is not already available, you're asking to pull it. And of course the name. So name is important because when you do a get pods, so this name is what is actually printed. Right? So yeah, so that's about. It's a similar structure. I mean, if you understand this, it's the same copy, just the instead of it is replicas, it is deployment here, right? So again, let's go back here to the demo. Here now, just for sake of time, I already created this file here. So vi02 deployment YAML. So again, the same thing whatever we saw now. So this important thing is by looking at this file, you need to see what is deployment. So when kind, this is deployment. So you should automatically think in your mind that this deployment. So it will have the pod specific information because you are deploying a pod. So the pod image will be there, and the name is this. Of course, the replicas will help you to tell how many instances you need. So that information is all here. So again, I'm just coming out. Again, to deploy it, again, same thing. One thing which I want to highlight is actually we have 4 pods that are running, right? So probably let me try a bit different here. how many instances? Okay, here we have replicas as one. So actually by earlier I created a replica set with replicas as four, but now I'm overwriting that replicas to one. So when I do get pods, I should see one, not four, right? So that's something that we'll see if that works. Okay, so before that, let me run this kubectl get pods, which is so we have four instances. So basically, after we run this, we should have only one, not four. So let me create this again. This kubectl create -f to import this YAML file. Go to deployment. Okay, so let me check this. So the PO reduced to from 4 to 1. So that's very quick, right? So I think you can immediately see those four were deleted, and if you look at this instance name is different compared to the other four that we already have. I'm supposed that this is same. Sorry. So it retained this, and the other three deleted it. So that is the deployment. And let's go further now. So we now create a deployment, and let's also create service. So service is also a YAML file. So this is the name itself here it is service, right? So kind is service, metadata is again repeated information. The spec is what is important in service. The spec, because probably I'll put it in a notepad so it's more clear. So by default you'll have the four things. So by default, so API version, kind, metadata, spec. So this is standard, and this is being kind. Here you'll have the service I'm using, so it will have service, and here v1. Only for deployment is app/v1. For others it is v1. So metadata here again the label stuff. Can we use this stuff with this two spaces, pasting it. Here this is service, so this spec will be different compared to, because this is service means it is actually telling how, like load balancer, what kind of load balancers you need, and also what port it has to run. So it will have some details in terms of the load balancer information, port information. So these are the two things that we'll have. So it'll have. So I mean, just to explain this, like, I mean, this load balancer service actually is creating a load balancer for it. Basically, from client where actually making a call. So typically, I'm talking about the outside non-Kubernetes world. So a client, which is a browser, when you're hitting a URL, google.com, actually it is coming to let's assume Google as a load balancer. So there'll be a load balancer is where actually a request is coming to, and load balancer is actually directing the traffic to there will, let's say there are three nodes. So and assume N2 is free at that point. So load balancer will route the traffic to N2. So N2 will execute and send the response back, and client will get the response back. So basically, your N1, N2, N3, all these three nodes where your application is deployed, and load balancer will decide who is free at any given time and will route the traffic to. So in this case, if you see here, there is something called load balancer will have this guy will have some port, and this guy also will have some port. So it need this port and this port may not be same. This is load balancer's port. So this is a target port. I mean, that is a terminology that is used commonly. So this is then target is this. So it's called target port. So and here this port is called either a load balancer port or a node port. So this is what it is. So basically, this port will be, for example, 8080, but this could be, you won't expose 8080 as outside world because client will know 8080. But inside this N2, you could have a different port, for example, 3000 series, also you can use. So, so that is the meaning of so these two things that you need to remember. So this N2 will have probably it could have a different port. Also, it could also have same port also. It's up to us to how we design it. But since it is possible to have different ports, so you can so it should be possible to configure both. So yeah, here in this, why I'm explaining all these things because we need to now talk about tell the service in terms of how the ports will work. So you should tell for a service which is from the name itself, it's really a networking component. So when this service is a networking Kubernetes object. So we need to give details in terms of the name, the service, and the port. So that information is what will come in the spec of service. So here you have ports. It's possible to have more than one port. Again, so that's why ports. Again, I mean, the one thing which you need to remember is this plurals. Wherever you have it is like S will be there. S means it indicates that you can have more than one record here. So again, containers here, if you look at it has more than one record. So ports, so which means it can have more than one port. So here I'm telling you I need to tell what is this node port of the load balancer and the port number. Similarly, the port this port is actually your this node port and it can also have port. So we need to mention both. Mostly it would be 80 a default port number and then protocol. I mean, we get this Kubernetes supports multiple protocols. So most common for web application TCP is mostly used. So you can tell TCP and also what is the target port. Target port is actually in our case this node has a pod. This is actually the pod's port in Kubernetes case. So the pod's port is what is the target port. Of course, this is ports, and then once you're done, here again the default selector is important. Selector is the one which tells what is the label information. So app, whatever the app name of the pod. Of course, session affinity is basically if you have requirement in terms of where this pod has to be. When if you have requirements that you want to configure any traffic that is coming, you always want to put to N2. Even though you have N1 and N3, you always want to enforce the traffic should go to N2. Then you should tell the session affinity. So session affinity, and here generally you give the node name N2, for example. But I don't have any such requirements. I'm just putting none. So I mean, which means load balancer can route the traffic to all these three nodes, not just to N2. Like affinity is like linking or associating. Right? So you don't have affinity, so which means you're free to select whatever node you want. So that is the meaning of that. And of course, the type. I will tell you what is type. That there are a lot of types are there, but by default I'm selecting load balancer. That's the meaning of this. So yeah. So let's look at this data back here. I'm going here for the sake of time. I think I already created this file here. Service. So before running it, let me run this kubectl get svc. So if you look at it, this is a default Kubernetes service which is running, but no hello world service is running. So now I will create this command and see you will also see additional hello world service running. Kubectl create -f 3 service created. Again, I'm running this. You see those hello world service is appended additionally, and it is in pending state, which means it is still creating the service. So if I run it after some time, status will be changed from pending to created or something. Yeah, it takes some time. This part. Yeah, created now. See, there is an IP associated here. So it was earlier pending. So this is my endpoint where now I could access this service. So now I could access this hello world service. That's my endpoint slash hello world. Let me check the port. I think I need to configure the port. Let me go to services once. So this is to create a service. So the service name should be listed here at 8080. Sorry, I didn't mention that. You can also access from here. This should also work. Okay, so again, come. Particular 67, 70. Oh, 9 I guess. Yeah, 94.
94 Narayan.
Yeah,
94.
4 is missing. Yeah. Okay. Yeah, so 4 is missing. Yeah, thank you. So, of course, we can also see our endpoint, which is slash hello, endpoint, this one. Yeah, slash hello. So, yeah, this hello world v1 is there. So this is the output of our endpoint. So basically it is telling you from which pod this traffic is coming. Actually. So if you look at our pods, sorry. So you put get user pods. So yeah, if you look at this is our pod name. So that's why it is coming. This pod name is coming here. Okay, so that's how you create a YAML based file generator and you upload this file. Of course, can create all these three independent files like this. Also, you can club everything into one file. Also, that is also possible. So you can, for example, if I open this new one, 04, this consolidated file. So which means you can have everything separated by hyphen hyphen hyphen, like three dashes. So if you look at, I put everything in one file now. So replica set, deployment, um, and service, all three separated by this three lines. So you can directly run this as one file. So it creates in the same order while it is creating it. So yeah, but you can do that as well. So I'll just quickly demonstrate that. So I'm just deleting, since it's already there, I'm just deleting everything. So this namespace, this is default. I mean, namespace, it is nothing but it is a directory. I can think that as a directory. So all these objects are created under this directory, the namespace, which is default. So yeah, by default, Kubernetes uses default as the default namespace. But generally, it is okay to use default namespace. But in generally, in enterprises, they create separate namespaces. Like, let's say your project name could be a folder name. So generally, say your project name, you create a namespace first with the project name, and then you create all these objects under that namespace. So that way, uh, Kubernetes being a globally used for an organization, so there will be multiple projects that could be deployed in the same Kubernetes. So that way it is easy to differentiate your Kubernetes objects versus other projects Kubernetes objects. Just to differentiate that, this namespace is used. So default is the default namespace, but it is always good to create your own project specific namespace. So I mean, at the end, here at that point, you need to tell what is your project specific namespace. It's not default. So you just replace your project namespace here. That's all. So so that this object is created in under that namespace. So okay, so let's also quickly run this get commands just to see everything is deleted. Get is deleted. Get deployment is deleted. No resource found. Services only Kubernetes services there. Get pods nothing. Get replica set is also nothing. So now I will create this consolidated file so that everything is in one shot. It will be created. So kubectl create minus f type it. Okay. 0, 4. There's some lag actually. So you see this all three got created at one shot. So now yeah, I can run the same three commands again. It's in pending state which means it is creating it. But is the deployments created, services created, it is in pending, it's creating it. Pods created and replica set is also created. Then one file you have everything. So let's run this. Yeah, it will take some time, but I think you should get this kubectl get service. It should fetch you the IP address now. Yeah. So you can access that IP address and if you see here the ports information also there here. So 8080 is the default port for this. Of course, internally this is a um, port of the load balancer, and this is the port of the pod. Uh, so yeah, that's the link. So when you access it, you call this IP, colon 8080 is what is the external port. But again, load balancer will take care of calling this of port forwarded to this internal port. Okay, so it is clear. Okay, so before going to that, yeah, probably I will also show this in an editor, right, how this is easy to write it in an editor. So, I mean, I mean, there are a lot of editors that you can use for Kubernetes. I mean, mostly IntelliJ, VS Code, these are the popular editors which are used. So all this have some plugins that you need to install. For example, it is IntelliJ, but I think this is the same for everything. But you can, if you have some IntelliJ editors, so you need to install some plugins. So there is this plugin stuff. Um, and I installed this a long time back. Settings. Plugins here. So here in plugin section, you can install Kubernetes plugins. So for example, Kubernetes OpenShift and Kubernetes Metadata. So both are there. I mean, I installed Kubernetes OpenShift plugin and Kubernetes configuration plugin. So these two will help you to identify your Kubernetes objects. And also something called YAML plugin is also there. So install this YAML Ansible supported YAML plugin. So this way, YAML the YAML syntax will be if there's any syntax errors in YAML, it will highlight. So these two are nothing Kubernetes specific, but it's more YAML specific. So IntelliJ can identify if there are any YAML. I mean, this indentation and all is important, right? So in Notepad, you will not know if there is any space extra. So these editors will help you. These plugins will help you to identify. So yeah, for example, I'm just giving a simple file. It's already there, but I think yeah, this file. Let me create this file here. File. Create probably a replica set. then immediately if I add it, it creates a YAML file. But I think if you once you type this API version, it will automatically identify that it is. Like this. So it should convert like this Kubernetes symbol should come. So yeah, so it automatically detected it. So as and when I typed it, it automatically comes. So for example, here if I type this, it is automatically as soon as it's detected, it should listing on the possible values. So this will be easier to remember and type it. So kind, so K if I type it automatically listing in kind. So the typing is faster. So control space, it will tell you what are the possible kinds that you could access. Pod is kind, replica set since the replica set will be your kind. So likewise you can tell whatever you want. I mean application controller is also another component. So this is the older version, that's why it is not identifying the replica set, but it should come, replica set also should come. So this kind API version, what else? Metadata. This one has multiple. So basically, if you look at, if I hit enter, it is actually waiting exactly under T, not under N. So it knows that this understand YAML. So basically, it is waiting just two spaces before, not because if I just hit enter, it is waiting there. But if I enter from here, it will go and wait in the front line. Right? If I enter from here, it knows that there's a child after this. It waits here after this two spaces later. So yeah, this simplifies your development. So and you can there's nothing complex here. I mean, editors will make your life faster. So you can do the same thing in Notepad also. So that's about this service, right? Um, so yeah, so summary. I think we learned how to create a replica set, how to create a deployment, and how to create a service, and we deployed this using a create command. Create command. Of course, in the previous sessions, we also saw the non-Kubernetes way of, I mean, non-YAML way of calling it. Also, that is also possible. For example, you can create deployment, and you can tell like this. I mean, the same thing is what is there in this YAML file also, deployment also. So, for example, here you're telling create deployment. This is kind that you're mentioning here. And also what is the name here? You're mentioning the name here, the all over REST API, and then you're giving the image name here, which is this. So you can do like this also. But the drawback in this is if you want is here we are defaulting many things. So I mean you're giving a basic information. So Kubernetes defaults many things if you're not giving here. But I think in professional enterprises and all, right, so they have a lot of settings which are project specific settings. So likewise you can append with hyphen hyphen, like you can add hyphen hyphen image full policy hyphen hyphen name. You can give all these things here, but it is not easy to manage this when you have multiple parameters like this to mention. So that's why it is important to use YAML so that it can give a lot of information here. So and also it's easy to read, and we have a lot of editors which can help you to figure out if there are any issues. So that's about this YAML structure at a high level. And also, so let's, I mean, do you have any questions before we move to the next section?
So what is your next section?
Next section is, smaller topic only, but it's more about going into this types. One which is load balancer. What are the various types that are available in a service? So we've used load balancer,
Okay.
but other services. are there?
More on the service deep dive. Okay,
Yeah,
okay,
service deep
okay.
dive. Yeah, right.
Yeah.
I think,
So
yeah,
yeah, one thing is the it the session is not as interactive as before because of the topic in detail. Because this is a new paradigm, and when we I kind of cautioned you guys when we try to go deep dive into this Kubernetes, we all have to talk in a language called YAMLified, not more English. So that is what uh, we are trying to learn the process of doing it. But for any language learning, right? Language learning is not simple. Language learning needs discipline and passion, and yeah. So yeah, Shama's passion. So you could able to bring out the things for others to learn. But yeah, but we all have to listen to this, and it is not hard if you think about whatever we are learning now. It's all there, like object oriented world, object, what is the subclasses, kind is basically that kind of thing. Kubernetes object, which has all those practical usages called deployment services, pod, blah blah blah. But one interesting thing what I'm trying to tell you guys is like in our world, I'm basically from middleware Java background, but now mostly in the Python world. So, and also Node.js also we are seeing. What is interesting happening is from the cloud, now the era is going to the cloud native. Cloud native implies that, for example, whatever the resources previously it, you want to create EC2 servers, a load balancer, a storage, ELB, load balancer. So those kind of things you kind of either use the CloudFormation template or Terraform, or use the AWS console or Azure console or GCP console. But still, it's all cloud way of talking. It is that specific cloud way of talking, infrastructure as automation. So this field is actually opened up in last 10 years only. Before that, infrastructure was closed infrastructure. In the last 10 years with AWS Invent, infrastructure has opened and infrastructure automation has opened, and all those that Terraform as kind of cloud agnostic, kind of cloud agnostic, so that you could use that for creating Azure as well as AWS, blah blah blah. So that kind of happened. But now what we are talking is a layer above. Now we are not even care about the cloud or not cloud. This is something like my application. I want these things, what I want the application to be, and I have my language. I know what I want to specify in my language. That is what the YAMLified. And now that is being translated. For example, when we say YAML file load balancer, we didn't give all the things for the load balancer. It is the magic happened. Now the cloud vendors are trying to work with this thing. I don't know whether you guys know it or not. When .NET and Java and web services, when web services is going to be the you could call from the .NET, yeah, Java web service is a huge thing, and people are working on that for 3 years to come out with the standard, how this whole thing will work. But now things changed. Now things changed. You know what? It's called a cloud native era. Cloud native era means the kubectl and the cluster 1.18. Then in next 3 weeks 1.19. Now is I think 21 or 22 right now. Every 3 weeks once the the cluster is coming, and the along with that API version evolves. And if you're with the cloud, for the more managed services like EKS or AKS or whatever the GKE, they force you to change. It's not your discretion anymore. Previously, yeah, I'm in my version. I will take 2 years to upgrade my things and make it work. Those days are gone. Either you just change in next 3 4 maximum 3 months time frame nowadays. Even that itself is hard. Within 3 months, if you cannot change, you are obsolete. It won't work. You're, so this is a new paradigm called the cloud native era, where the cloud native era, one of the biggest advantages, it it changes your on-premise as well. At the end of the day, this doesn't care whether you're on-premise or which cloud it is. It is basically saying I'm on the fly. I keep changing. I have so much innovation, and you be ready to absorb me, or you'll be obsolete. So it's kind of very interesting. So that is how we have to take this change. IT changed a lot. IT previously, we as a process control IT, but now IT controls the rest of it. And I see it's very interesting, and organizations are struggling a bit. But you know what? Within a 2 3 years, this is, if you don't do it across the board, you cannot even function as a company. That is how it's going to transform. Yeah, go for it. If you want, yeah, we can conclude now, or you can just summarize the service a bit and conclude.
Yeah, we'll summarize the service and yes. Okay, so yes, I think we discussed in service load balancer is one type. Of course, there are in service there are other types are also there. So this is important to know this type a bit. I think again the service, as I said, it is coming out of the networking topic. So I mean, if you look at the load balancer, right? So I think when we're actually hitting this endpoint, actually you're hitting a load balancer behind the scenes, and you see the load balancer is automatically created here for you, right? So there is an external load balancer that is used here, and it creates here. So at this point here, one thing to note is that when you create this service as a type load balancer, so here again it uses the Google's load balancer and GCP's load balancers. But of course, you can create. I mean, if you're doing the same thing in Azure, Azure's load balancers will be used, or in AWS load balancers will be used. So, but again, Kubernetes doesn't say. How a load balancer should look like. It is giving you the extensions to integrate any external load balancer into Kubernetes. So Kubernetes just gives some interfaces to link, but it doesn't come with its own load balancer. So yeah, it is a pluggable. Probably if you're on premise and if you're not using cloud, you will have some existing load balancer in your organization. So that also you can plug in. So, but just you need to tell what type of load, what is a load balancer and other stuff. So you should do the inputs. But I think, but as such, Kubernetes doesn't own the load balancer piece. It's something that I want to highlight. So yeah, if you look at here, this is creating a load balancer, but actually it is, if you go inside Google's networking section, you can see the same load balancer is also created here. So basically, just sort of highlight, it's not Kubernetes load balancer, it's Google's load balancer. So what is that? Networking, yeah, VPC networking service, load balancer. So if yeah. Yeah, so this is the load balancer that is used from Google's, not our internal, not the load balancer of the Kubernetes. So it creates GKE cluster that we created earlier, right? So this is our IP address. Of course, this new IP address is, I think we just created this file. So 104 is our new IP address, right? 104.197.122.238. So that is our new IP address. So yeah, this is what is used. And also, if you look at, you can also use the the kubectl, of course, kubectl also has get nodes. Nodes is again the minions or the worker nodes. Right? So that the nodes are also created. Again, Kubernetes doesn't say how this what should be. It doesn't give nodes are nothing but a virtual machine. Right? If we just go back to this architecture, these are the various three nodes that we have. These are three nodes, and this node actually when you create a Kubernetes cluster, so this nodes are also, it was asking how many nodes you want, and we told three, and so three nodes are created, and those you can see the node names here. Get Kubectl get nodes will give you the node names. So again here, Kubernetes doesn't own this virtual machine. I mean, the virtual machine is something; it's an outside component, not inside. So basically, you need to differentiate what Kubernetes owns versus what is outside Kubernetes. So the node component is node as such is used by master, but actually the node has to be created outside. So again, if I go to Google, you can see the nodes are created as a virtual machines outside. So if I go to the compute section, like compute, is compute, yeah, compute virtual machine, virtual so VM instances. So if you go here, so Kubernetes uses the virtual machines created. So basically, a virtual machine component is a compute component which is created outside Kubernetes, but Kubernetes uses that just like our load balancer is used. Again, if you see, these are three nodes that we created, and if you see this names match here, 16 LS62, RW5P, and SVQ0. Again, we are not inside Kubernetes now, we are under virtual machines, so which is outside Kubernetes. So yeah, so these are two things that you need to know. So that where this Kubernetes, that's where this mix of this cloud controller manager, and this cloud controller manager will talk to the respective cloud component. In this case, it is node, it is then virtual machine. If it is a load balancer, then it's a load balancer. So yeah, so I just want to highlight that some of them, what is the boundary of Kubernetes? Right? Boundary of Kubernetes is you should be very clear. So it's not doing many things are existing components only, the load balancer and the virtual machines, but orchestration part is what Kubernetes owns. Okay, so yeah, let's now go to the, sorry, it's a different topic, but I think I just brought it to show the difference. But again, going back to this topic of service, right? The service has before going to this, I just want to give some basics, right? So I think if you look at typically in a web services, if you use a load balancer, which is good, so you can use this. But also, this is possible that this you can access this all within a cluster. So for example, I'll just show you. These are the four options that is there: cluster IP, node port, load balancer, and external name. I'll tell you what the external name is. But yeah, this is the four top types that you can use. If I go back to this architecture, right? So this Kubernetes architecture here, if you look at associate this. So these are the various pods inside each nodes, right? Now the question is how the service looks at networking component, right? So this service, how will you connect to this pod? So that is what is defined in service. So how will you connect to this pod? So assuming this pod has some IP address and port, how will you connect to this pod? And you can also see that there are in every node there are pods, right? So and also and you're forming all these three as one pool, right? So which means you can access the pod from this node to this node because both are two. This pod has an IP, this pod has an IP. We can connect from this pod to this pod. So which means you can, just like accessing any other application, you can access the IP address of the pod and you can connect to this pod. So that is one way. So basically, connecting to pods across the nodes, that is option one. Also, it is possible that let's assume there are in this diagram is only one pod, but imagine there are two pods in the same node. Uh, so how these two pods will talk to each other? Let's assume there are two pods in this. How these two pods are in the same node. So which means these two pods have different IPs, so they also can talk to each other. Typically, that's how in microservices there will be multiple pods that will be deployed in a node, and for I mean, for the purpose of geo redundancy, they deploy the pods across nodes so that even if node crashes, they still work. So typically, if you are already seeing a combination where you can there are multiple pods deployed, um, you can also make one pod talk to other pod within a node, or across you can also do, right? To handle this networking stuff, so they that's where the service is there. So service will take care of various combinations. So the service type will decide what type of you're giving a requirement here. By giving this type, you are giving a requirement how you want to how you want to make this networking happen. So by giving cluster IP, what you're telling is all these pods can be communicate to each other in a cluster. So which means you can access as long as you're within this cluster. I mean, the cluster is nothing but this entire thing. I mean, this node, this master node, and three worker nodes together is a cluster. So within this cluster, you can access anything. So that is what is cluster IP. Basically, you're telling the scope could be cluster, which means your anything within this cluster can talk to each other without any problem. So that is what is scope is cluster. Uh, and the scope is node port, which means this service you want to expose within specific node within the specific range of ports. So I don't want to give all ports open. I want to be very selective in giving a range of ports. Within that port range is what and these ports I define in nodes. So that within that range of ports, only this can be accessed. And you can't associate a port outside this range. So if that's the case, it won't work. So telling that giving a range of ports. So typically, this 30K to 37K will be the range of this ports. There is the exact number which is in a slide. So, but yeah, this is the range that you give for the node port. Then next is the type load balancer. I think this we saw already. By giving the load balancer, you are telling there is a layer on top of this. You can imagine that's a load balancer layer. So all the traffic will come to that load balancer, and that guy will route the traffic to this. Going back to this architecture, right? So load balancer, and there are three nodes. So this load balancer layer is the one which is sitting the front seat, and whenever a client gets a request to the master will talk to this load balancer, uh, and load balancer will route the traffic to the respective nodes. So that is this model. So load balancer model is the load balancer controlling the traffic to nodes. So this is a very commonly used pattern generally in enterprises. There will always a load balancer that will be used, right? So this is the most commonly used pattern. And then the last one is external name. Let's say you want to invoke a third-party service, which is where you want to restrict your traffic to only to just this third-party service or external name. So then you can differentiate. Use this. This is something which was a very recently introduced component, where if you want to allow traffic only to one particular IP endpoint, you can use that. So hope you got an idea now. So I think we are now basically by giving this, you are giving a range of your networking. So basically that is what this types will tell you. Types you are telling by giving this cluster IP, which means everything within this cluster can be accessed, meaning outside someone wants to access it. For example, I'm sitting from a browser calling this service from outside, right? So then I will not be able to access it because I'm restricting. This is component. This browser sitting outside Kubernetes, so I can't access the service. But I mean, why this will be used again? We want to restrict the traffic within this nodes, internal nodes. Then you can use. It's not very commonly used, but I think it's good to know that this feature is also there. So everything within this node, if you access, if you basically should connect to this node and then invoke curl. If you invoke any API, right, you use a curl command. So curl and this endpoint, if you give, you will get the output. This response is printed as an output. So that is what this cluster IP means. So you can access everything within these nodes, but not from outside. That is the meaning of that. And node port, we are telling that I want to access this, but I want to restrict the range of the ports, and that is what this node port is. Load balancer is basically telling anyone from outside can access it. I mean, this is what the case where we're from a browser sitting outside is trying to invoke it. And the fourth one is specific URL endpoint. So if we go to this architecture, I mean, this slide, you'll understand it better. So this cluster IP here, this is a diagram. So you can imagine a traffic which is coming to a proxy layer. And proxy, this is a Kubernetes cluster, and there's a service, and we have pods. So basically, this traffic is coming to proxy, and proxy to service, and service to pod. So here the default, this is a default. If you're not mentioning any type, then cluster IP is by default taken as input. So, and we are exposing the services on cluster's internal IP. And the service is reachable within this cluster. That is the keyword. So you can access this traffic is allowed as long as your traffic is within this cluster, outside the cluster. Yeah. So that, but again, not very commonly used, but just to test something that will be used. By default, again, this is because by default, it's not a good practice to expose your service outside when you are doing some proof of concept or something which is internal. By default, you don't want to expose it outside for security reasons. That's why this is mentioned as this is the default service, which means any service that you deploy, you could access within these nodes within the pod, but not from outside, and that is the default. And the node port is the one is this. So this node port is actually you are giving a range of the port, and whenever traffic comes, so as long as it is within this node port range, then this port is accessible. So if it is not within the port of 30K range, then it is not accessible. So yeah, so basically you are reducing or exposing the service on a static port on each node in the cluster. Then third component is load balancer that we saw already. So where service becomes accessible externally. So this is where I'm from browser I'm trying to hit now. So externally through a cloud provider's load balancer. So we saw that we're using a load balancer from GCP. So you can use a cloud balancer as a cloud provider's load balancer, and so this way you can access it from outside. And you see here, this is the one which we saw now actually. So when you're hitting a traffic, actually is going to the load balancer of the GCP, and from there your traffic is getting related to your pod. And the last one is external name, and also there's something called ingress is also there, where I mean I'll talk about ingress first. Ingress is not in this category, but I think I will tell you first external name. External name is basically maps the service to the content of external name field, like for example foo.bar.com by returning a CNAME record. So basically, if you have you want to restrict the traffic to particular URL, then you can use this external name. So the traffic is restricted to just this URL, not to everyone. So it is restricted to this URL that you provide. That's what this external name is. And ingress is slightly different. So ingress is another component, but it's not a type, but it is another traffic pattern that was recently introduced. So this traffic pattern of ingress is like you can, let's say it's like you traffic by the domain name. So that is what is ingress is. The traffic by domain name is like foo.mydomain.com will be routed traffic to this service, like mydomain.com is routed to this service and other to this service. So likewise, you have specific domain URL specific value, then you can use ingress. So these are the various traffic patterns that are commonly used in the Kubernetes. Of course, here it is. I mean, probably once you see a demo, you will understand this better. I think the load balancer we already saw, where we create a load balancer and then we try to access the pod. Probably I will give a demo for this in the next session so that you get a better clarity. So this basically at the end it is nothing but these are various traffic patterns that are used in Kubernetes. So as a Kubernetes engineer or Kubernetes administrator, you should think from where you get the traffic. Accordingly, you select a particular service component. So is it accessible? I mean, this is most commonly used. I mean, assuming you have a web application that you deployed, that's so which means anyone can access the web application from anywhere in the world. So then the load balancer type is the default pattern. But let's say you have separate microservices,
Yeah. So, Sean, one thing now.
right?
So this is all good, right? Like, so this is the theory about like or the architecture about Kubernetes and what else actually, like
Mm.
the entire details, right? Like the actual nitty gritty of Kubernetes.
Mm.
So I think means yeah, it is going in like means you can't learn it or like you can't appreciate it unless you do it, right? So
Mm.
one thing is like maybe to keep this conversation more active, the companies are now struggling with taking existing application and moving into this architecture. I don't know if anybody, it's like if anything is available or like if you have experience with that, maybe we can kind of have dedicate like half an hour for that. Like say take a typical application, how would
Mm.
you move into it?
Yeah, so Jnani, for that that's a good question, and
Mhm.
we are in the right topic right now. If you see the last thing called external name,
Mhm.
this is the point where the tipping point between migrating your see, for example, assume that agilerules.com is there right now, but it is developed in a legacy and it's being DNS through that. Your first bet to move to the Kubernetes is convert your service Kubernetes domain or environment. So how the people usually do in a conversion projects is they try to do the simplest of the microservices. So for greenfield projects, if you have a greenfield project, then probably it's a good fit to be coming out as a microservices. Microservices means it could be a Spring Boot or it could be any chosen particular layer of your polygon, right? The whole premise is previously it's a Java shop, .NET shop. Nowadays, what they're saying is, given the merit of the problem, you can choose your particular technology because it's all containerized and Dockerized. So it should work. But when you want to come into the Kubernetes world, what you will do is you expose your microservices directly here because it's a green field, so much easier, YAMLified. You have a Docker, you have a layer, Docker layer, and you know there is a YAML layer to expose it. So that's simple, but not everything you could do easily that way. How to support the existing assets is through this service loss service external name, so that you, for example, sales, marketing, order, and sales is the legacy. So if you want to keep the legacy as is for now, but still you want to consume using the Kubernetes layer, that will be great. So that is one way to start with. Yeah, but we can talk in that way going forward, migrating the existing applications, how to think on this.
Yes,
As
yes.
anybody has real experience, not very many has very real experience on this. Is a newbie, right? But uh,
But I
as
have some ideas.
as in the PGE, we see that right now. Yeah, this is what they are using currently this way.
Yeah, I think that's a good point, Sri. I think uh, my idea is to take a direction in that manner. So I want to take a sample application hosted on my local, and then I want to import that to Kubernetes. Probably, probably in the next session, I will go in detail in this. So this is an example. I mean, before that, I'm just
Yeah,
giving some basics first.
basic.
Yeah,
Yeah. You cannot walk until you scroll, right? And see, this is the one thing is very clear. One is making it interesting. What Ganesh is saying. Otherwise, it's going to be dry. So we can take this as a two-step approach. One is what you're doing, you have to keep continuing. Otherwise, nobody can understand what it is. Okay. But other side of the story is we could have a talk about moving existing migration as a chit chat for 15 minutes, and we can bring an application or think what are the options available, and I will also try to chip in on that particular side. Yeah, it's a journey. That's it.
yeah, that's true. Yeah, I think probably I think in the next session I will touch upon this more about this various patterns and also let's take a we're also for using all this hello world service, which is simple service, right? So I think probably my idea is to introduce a microservices project where you have multiple services like this, and you want to expose the traffic based on the pattern that you provide. So and then that is the problem is to start with simple stateless services, and then move to a bit complex functionality like stateful services. Stateful, which includes some storage. So it's a database or a storage. So yeah, we'll look into those concepts. But I think
Yeah, my suggestion is you have to go a little slow on these things, because the more you bring it in, it is going to confuse as well, right? So yeah,
yeah,
we'll do that, but we'll cover the basics as we do that.
yes, yeah. Okay, then I will logically break
Good.
here. So probably
Yeah.
we'll go into this
So
detail next week. Yeah.
Okay.
yeah,
Thank you.
thanks, man. Yeah, it was a great thing, and today is my birthday. Okay.
Yeah.
Yes.
I wanted to say happy birthday, Srini.
Happy birthday, Srini.
Yeah.
Oh, thank you, guys.
Happy many happy returns of the day.
Yeah. See, that is what we are all drinking Kubernetes for birthday. Deep dive.
Happy birthday, Srini.
Thank you.
But
Thank you.
yeah,
Yeah.
So
Yeah. See
I
you guys.
mean,
Yeah. Thank you.
one thing I
Yeah.
think this birthday should be something special, right? So I think I mean in terms of do you have anything to highlight? I mean this hello.
You're asking who?
No, I'm asking you, Srini. So is this anything special? I mean, this birthday. I mean, what is probably you want to have?
Yeah.
Yeah.
You know, I'm taking a CK80 exam tomorrow. That is my birthday treat.
Oh, okay.
I'm taking the exam. I don't know whether I'll pass it or not, but
Uh-huh. Oh,
I'm going
that's
to
good.
take it. That's
Okay, that's good. Okay, good. All the best.
yeah.
All the best for
All
the
good.
exam.
Spending time with family. That's it, man.
Yeah, that's good. Okay. Okay then. Thanks everyone.
Okay. Thank you, guys. Yeah. Bye.
Bye bye.
thank you.
Thanks. Yeah.
Yeah, thank you. Bye bye.